Hey robot makers, hope you're having a good day so far. So, do you want to learn how to build your own electronic toothbrush using a Raspberry Pi Pico W? Then this is the show for you. Yes, it's a weird one. Let's dive straight in. My name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let me get my screen sorted here, and we can get straight to it. So yes, a bit of a weird show today. Let's just roll with it. So yes, this is all about how to build a Pico-powered toothbrush. I have my prototype next to me on the desk. We'll have a look at how that's going so far. So we'll have a look at what it is, why I did this, some of the features and the specifications, the design and build process. We'll have a look at some of the issues, the work in progress, some of the next steps, and we'll have a play with the user interface, the little screen that's attached there. The screen that I'm using is actually from last year's Pi Hut. They had a little is it 0.9 inch display, OLED display, so I've actually used that one in this project. And if you're here for the live stream, we'll also have a bit of a Q&A and a mailbox. I've got loads of different kits actually to show you today. So, and of course, you want to check out the Yukon from Pimroni. We'll be covering some of that in today's show, just a bit of a teaser in today's show. Okay. So I made a thing. What is this all about? So I've made a 3D printed electric toothbrush that you can program yourself using a Raspberry Pi Pico, Pico W, and MicroPython. It's hackable, it's extensible, you can add your own features over time, and that Bluetooth and Wi-Fi connectivity means you can do all kinds of clever stuff with this, like sending how long you'll brush your teeth for, when exactly you brush your teeth, all that kind of stuff, to an MQTT broker, save it in a database, an influx database, whatever you got to do, chart it. It's your data. You can do what you want with it. So let's get on. Why do I make such a thing? So I have to look at things, and I do mean this, and I wonder, what if I could do that myself, or put a microcontroller in it so I could control what this thing does? And I looked at my toothbrush the other day, and I thought, that's about the size of a Pico. I wonder if you can put a Pico in it. So yes, in short, that's something I'm always thinking about. Can you put a Pico in it? And then it becomes a challenge of 3D design, electronics, software engineering, assembling the whole thing, writing it up, putting a show together like today's show. So that's often the thought process, and really that's all there is to it when it comes to this. It was something I thought you probably can get a Bluetooth toothbrush, but I wanted to make my own. So let's have a look at the specification of this. So it has that 128 by 32 monochrome OLED display, the one that actually came in last year's Pi Hut Christmas calendar. So that came, I can't remember what day that was, but it's a little, it's not quite an inch in diameter, the display, but it's quite a long, but it's perfect for projects just like this. I've got a Raspberry Pi Pico W, and that has Bluetooth and Wi-Fi connectivity as well, should we wish to use that. We probably will in this project. I've got the 400 milliamp hour LiPo battery, the gallium batteries that Pimroni sell. They're perfect for almost all projects that I use. Plenty of juice in them, and of course they're rechargeable. And they're rechargeable with the LiPo Amigo Pro, which Pimroni also sell. So they're perfectly paired together, very easy to put together, almost the same size as well if you stack them. So they're inside the wireless toothbrush. We've got wireless charging as well. So something I bought a while ago was these little wireless charger things. So it comes with a little circuit, and really all we care about is this end here, the business end with the plus and minus, and then this sort of induction loop, which is quite robust. We basically just need to put that one in proximity. We can have this inside a 3D print next to the matching pair. So there's another one just on my desk over here, which is plugged in at the moment, so I don't want to electrocute myself. But we'll actually have a demonstration of that one charging the toothbrush when we do a bit of a demo hands-on. It also has an N20 motor. I think this is about 150 RPM motor. These are very cheap to buy. I think they're about £5 to buy now. They were a bit more expensive earlier in the year. They're about £7, but they seem to have come down in price now, which is a good thing. And all this is, of course, MicroPython powered. So if you like CircuitPython or MicroPython, then you can use this as well. Okay, so some of the features. So here you can see the cobbled together prototype version I have. So it's a programmable toothbrush. I mean, what else do you want to have more than that? So it will have a countdown timer on the little screen. So once you switch the device on, you can see a little countdown timer that will count down from 2 minutes. So I'm pretty sure I read, and I think my toothbrush, my regular toothbrush does this. So it will count down in 30-second increments, and the motor will pulse. It'll basically just turn off for a second, and you'll notice that when you're brushing your teeth, to say like swap sides and swap up and down. So you've got 4 different segments of your toothbrushing thing for a full 2 minutes. And you'll be able to select different modes and speeds, maybe like a regular clean or a massage or whatever. You can do different things like that, and different speeds of the motor. And we'll be able to upload all that brush time information with a date, like a date stamp, to an MQTT broker as well. So I'll be just publishing that to my regular MQTT broker. So you can charge it wirelessly as well. So regular toothbrushes come with a wireless charger, and it's one of those things you take for granted. I remember when the very first phones started to have wireless charging in them, and was like, wow, that's the future. But toothbrushes have had this for ages, and it's a really safe way to charge an electronic device in a wet environment. So we can do that too. It's very cheap and easy to add as a feature to our projects. So something you could add to any of your robotic projects, in fact. So this is the design. This is what I put together in Fusion 360. It was quite a straightforward design. I think this is probably the second iteration I've done of this. And it essentially has a holder piece. So there's a piece that all the different electronics mainly stick to. They're screwed to it, in fact. And that's a nice rectangular flat piece with holes for the screws, and also holes for wires to go in and out of. And the little motor controller also has some holes just where the solder head of pins sort of poke through the bottom there. There's a bottom and a top of the case which kind of go over the motor holder, and there will be a bit for the wireless charging, which I haven't quite designed yet, and there'll be also another bit on the top, and we'll talk about what that is all about shortly, because you can't just plug your motor directly into the toothbrush as easy as you might think that would be. So this is the build process that I typically go through when I'm putting a project together. I'll start by laying all the parts out that I will think I need for a project. So I did tweet this one out, or Mastodon it, or post it, all different social medias during the week, sort of teasing out what could this be, what kind of robotics project could this be. And you can see there we've got the wireless charging, we've got the LiPo charger, the LiPo battery, the Pico W, the motor driver, and at the very top end there the motor, roughly in the orientation that they will be laid out on the 3D printed part. So that's the first step. I then think about what's the optimal way to lay these parts out. So can I stack them so the battery and the LiPo charger, for example, can sort of sit on top of each other? And I was thinking about having the motor maybe closer to the motor driver, or maybe further away from the Wi-Fi, just so it doesn't interfere with that. So I've been thinking about things like that as well, and trying to make it roughly the same size as like a regular toothbrush, which I recently bought from a supermarket just so I could take apart and figure out how these things actually work. This one is a very, very simplistic toothbrush, just has like a regular AA battery in it, and just has a on-off switch, and it doesn't actually have that sort of circular brushing motion. I did brush my cat with it, so it's full of cat hair, which is just a bit random, but it has these replaceable heads as well. So that was just in case I wanted to take one apart and see what was inside there. So once I've done that, I will then go into Fusion 360, and if I haven't got models of all the components that I'll be using, I will then have to spend a bit of time with a digital caliper. Got this one I bought for 98p on AliExpress, I think it was, or Wish.com, but it's actually very, very functional and pretty accurate. Because it's only £1, I don't mind if I break this one. I do have a metal one as well, but which is, I think, a decimal point more accurate, but the battery compartment thing's gone out, and yeah, it always requires like resetting whenever I use it. So this one is quite a nice one. I'm not sure which online site I bought it from, but it's a carbon fibre one, and yeah, it's pretty nice and accurate. That way, it definitely resets to 0 when you move it there. So what I will typically do is just get the parts. So say I've got this gallium battery here, for example, I'll sort of measure. I'll then take a measurement of that, go into Fusion 360, sketch that out until I'm happy with the actual model that I've created there. Sometimes I'll go into GrabCAD and I'll grab the component if somebody else has designed one already, because that saves a lot of time. Or if the manufacturer has made available the step files, I might take them. So I think Raspberry Pi had the Pico W step file, so I was able to download that and use it in my Fusion 360 project. And that means I've got really accurate representations of the things I'll be putting in there, particularly for mounting holes, checking for tolerances, measurements, all that kind of stuff. So that's typically what I will do in Fusion 360. And once I've put these things together in a model, I'll then start thinking about how can I print this? What's the most optimal way of printing this? You don't really want curved surfaces on your 3D print bed. You want them to be nice and flat. So I typically will slice a model in half, and then I've got two halves I can then sort of lay side by side on a 3D print and then print them. I also might think about, do I need three parts, like a middle with closures around it, so I can, if I need to expand it or change something, I've got less parts to reprint. So all that kind of goes into the how can you make this easily 3D printable. So that's the sort of build process I go through. And then here we are, the work in progress. So I can show you on the desk over here. This is the Pico powered toothbrush as we have it at the moment. So I've got the gallium battery just under there. And we have the, if I just switch this on, there's an LED that comes on there. If I turn off that overhead light, in fact, let's go for that one. You can see there we've got this working LiPo battery charger there. So I just need to run a power line from there to the Pico, and from the Pico to the motor controller, and also power the motor controller from the LiPo charger as well. But everything sits in there nicely. This is the 3D printed case that I've designed, and you can see it's roughly the same size as a regular toothbrush, so it's not like too wieldy. So the top section, I've not printed that one yet because I'm still working on that. And I've got the wireless charging stuff here, and I've got my bench power supply sat ready to charge that up as well. So let's go back to our notes for a second. So yes, the main parts of this have been designed. I haven't designed the 3D printable part for the wireless charger yet. And then there's the top end, the business end. Currently the motor will just turn round and rotate in a direction that we choose, at a speed that we choose. But that's not how toothbrushes actually work. They have like a side-to-side motion. So if you get to like an Oral-B toothbrush, not sponsored by Colgate or whoever, Oral-B, I think Oral-B are their own company, aren't they? Is it Johnson & Johnson, one of those big companies? They have a cam inside. So there is a motor, but the cam will make the thing sort of just go side to side. There's a rod that goes inside the toothbrush head, and then that will basically, there's an attachment in there. There's one in the head of the toothbrush, one inside the toothbrush head itself. They sort of bond together like that. I think they're both made of metal, so they'll twist like that. And then there's essentially just two gears sort of at right angles, and that will just convert it into a side-to-side round motion to simulate brushing. And it does it obviously very, very fast. So we can control the speed of that, which is pretty cool. But I just need to make that little head end cam, which I haven't done yet. So we'll have a look at that in a second. I have been working on the software for this, so the display software, the user interface, and a little display that I talked about, that 1-inch display. I've been working on that in MagPython. We'll have a look at that in a second on the demo. And I've created a little battery icon with a countdown so you can see that the battery level. So to get the battery level from the Pimoroni LiPo, Amigo LiPo Pro, we can simply just take a reading from the, one of the pins has like the current battery level. So you can take a reading from that and you basically do a voltage divider with 200k resistors, and then you can put that into a Pico ADC pin, and you can basically just read the value there to see what the current level of that battery is. So I've not written that code yet, I've not wired that up, but that's essentially how we will do that. So that means we can then feed that into our software to say this is what the current battery level charge is, and we can display that on our little user interface. There's also a countdown timer, so I've started working on that, not finished that yet. And of course I need to wire everything up inside, because currently there's quite a lot of components that are just sort of on the board. They're all screwed in, but they are not currently wired up. So you can see on screen there we have the LiPo, we have the battery, we have the Pico there, we've got the MX, is it, what do we call that, is it 1306 I think, or 1603, I can't remember which way around it is, but they basically cost about £1, those motor controllers. And then we have the motor at the very end there, just inside the 3D printed case. And yeah, I've not quite got this 3D printed case just right yet. That should all be nice and flush, but the battery is sort of ever so slightly sticking out. The idea is that this sort of pushes into place like so, and it can sort of just friction fit inside there, but the battery is ever so slightly, I think it's slightly fatter than I expected it to be. So I just need to just need to redo that ever so slightly. But this is why I've made it into several segments that can be easily printed. So we'll have a look at that in a second. I need to add the wireless charging circuitry. We'll have a play with that in a second. I'll show you that as a live demo that we can actually get that up and running very, very simply. And then I need to think about how to splash proof the design. So if you're going to be using this in a bathroom environment, how can we make this actually safe? Particularly where the screen is, because that's kind of a hole being punched through the case. And also where the motor is and the toothbrush. This is just it's not the actual toothbrush head I'll be using, but essentially when that goes over there, how do we protect that from water going inside there? So I just need to think about some of that. That's probably going to be one of the hardest things to get right, actually, because it'll need little rubber seals and whatnot. We'll have a think about that as well. And then the cam gear for the toothbrush head, we need to design that and then make sure the head fits nicely on there too. So just a few extra bits to get up and running there. So I'll try to get a simulation of the cam there, but the reason it glitches out for a second there is because the arm that I've designed there is not the right length yet, so it's basically just saying you can't go that far, you need a longer piece there. So that's why it looks like it's slightly glitching out there. I'll just replay that there so you can see you have a motor which is turning this dial, and then you've got these two arms, and we would have this spindle off this section here, so that's basically just rotating ever so slightly, and that's enough there that we can have a spindle come off that central to our toothbrush, and that will feed into the head. So that's how we will fix that particular issue there. So that's the cam design. Might be a bit fiddly because I need to do this quite small, and 3D printed parts that small are often quite difficult to do, so that's part of the challenge there. So that'll be an interesting one. So if you like what I do and you want me to make more crazy videos like this, please give this video a like, drop a comment, let me know if you've ever thought about creating your electronic toothbrush, or if you've got any ideas for something you could put a Pico in that don't currently have one, let me know what that is. Maybe we can make it. And if you haven't subscribed to the channel already, please subscribe. It really makes a difference to me. I get a lot of sense of joy when I see my subscriber count go up, so please subscribe if you haven't already subscribed. And I do go live every single Sunday at 7 o'clock GMT, which is like now. We've gone live and it's 7 o'clock, so every single Sunday. So if you want to catch me live, you want to join in the chat, we will be talking after the main part of the show with everybody in the chat, so stick around for that. Let's have a bit of a demo, shall we? Right, so let me just go to me for a second while I get my screen set up, and what I will also do, I'll just go over here to my overhead, and I will just zoom in on that little screen just there. There we go. So I've got this little screen. I plugged it into a I'm actually using a Pimoroni Explorer board. I absolutely love this board. It's Pico Explorer. The reason I love it so much, you've got the Pico in there, you've got a little breadboard for experimenting, and there's loads of pinouts, and there's even a screen on there and a buzzer, as well as some little breakout connectors. So it's really great for experimenting with your Pico and building projects. So on this one, I'm just connecting a couple of pins up from the Pico, and I've got this little display just connected up there. So this is an I2C screen, so there's a voltage, a ground, and there's a data and a clock line. Right, so on the code we have on the bottom of the screen here, let me just move this, let's see the best way of doing this. Move this down a little bit. And let me just move the split down a bit as well so we can see everything on the screen. There we go. Right, so I've got a couple of demo programs I want to show you. So what I'm going to do is go to the first demo program. I'm going to run it and then I'm going to talk you through how this actually works. So if I just click on run, we see there it says hello Robot Maker or hey Robot Makers on the tiny little screen just there. So it really is a small screen. If I put my finger next to it, you can just see just how small the screen is. It's only black and white, so it's quite good for working on microcontrollers because they don't have a lot of memory. But it's big enough to put text on, so that means we can do all kinds of cool stuff on there. So it's 128 pixels by 32 pixels, so plenty of room to play with there. So let's have a see how this code works, shall we? So the first thing that we do, if I just move this down a little bit more, there we go. So we import from machine the pin and the I2C classes, and then I created this SSD 1306, which is the type of display this is. I basically got a piece of code here, I think I found this on the internet, and it also uses FrameBuff. FrameBuff is built into MicroPython, and it's a whole library for doing things with graphics. So you can create a frame buffer, you can push that frame buffer onto an OLED display, you can draw rectangles, draw text, all kinds of stuff like that. Not as sophisticated as, say, Pico graphics from Pimoroni, but it's more than good enough for what we need for this. So I typically just right click and upload that to the Pico. You can just see on the Pico board there we've got the 1306 library there. So that's what we import. Let me go back to that demo one again. We then do a couple of bits of housekeeping, if you like, for the I2C for the screen. So we need a data and a clock, and they're on pin 0 and 1, and we need an ID for the I2C bus, because there's two I2C buses, 0 and 1. We're just going to use 0. And then we create our own little I2C object, just doing this equals I2C. The ID is equal to the ID of 0, the SDA is equal to pin 0, and the clock is equal to pin 1. And then we can then create our OLED display object by using that class, which has all the functions that we need for setting up our display. We can set the width and the height, and then pass it in that I2C for the hardware. And then we can say initialize the display so that it can now start displaying stuff on there. And then we simply do OLED.text, hey robot makers, and then we just tell it the position that we want this to be in. So if I move this down, say to row 10 rather than row 1, and then rerun this, you'll see that the text is sort of slightly lower down. And if we've got 32 pixels high, let's try that. You can just see it's just gone off the screen there because we're obviously starting, it's only got 2 pixels to go there. So let's make it, I don't know, 20 and run that again. So there we go. Or we can just make it 0, and it'll be the very top of the screen. And position, the X position is the first one, so we can just set that tiny bit back just there. And we can change this text to be whatever we want there. So we can just say, hey, watchers, and boom. So really, really quick, really easy to use to display stuff on a tiny screen. So next up then is the next demo, which is going to be the battery level. So I created an entire class, which is called battery level. Let's have a quick look at this. And this encapsulates everything we need to do to display a little battery icon on our screen and then say how many bars of battery that we've got left. So I've gone with 5 levels of battery, roughly like 20% increments. So the first thing we need to do is just initialize what the current level is, a number between 0 and 5, what the X and Y position is, so where we're going to display this on the screen. And then we have a draw function, so we're basically just going to draw a rectangle for the outline of the battery, and then a tiny little nub to show that that's the plus terminal on the battery. So if you look at like a regular battery, it's kind of like a, I'll just show you that, it's kind of like a rectangle with this little top bit just poking out there. So we typically have like on a user interface, sort of on the side of the screen would it be? It'd be like that, wouldn't it, on the top of the screen, and you'd see this little battery icon, and then within it you'd have the bars. So that's what this does. It simply just draws the outline and the little positive terminal, and then we then draw the battery level, the bars, depending on what the current level is. Now I could really optimize this code. This was just make it work kind of level. Whenever I'm programming, I have 3 levels of passing through the code. So make it work, make it right, and then make it fast. So this is make it work, so it's quite crude. So we say if the self.level is greater than 1 or greater or equal than 1, then set an offset value. So this is just start the X position 5 pixels from wherever the origin is on the screen. The width of the bar is going to be 2 pixels and it's going to be 4 pixels high. So then we just draw a filled rectangle at the current X position plus that offset that's 5 pixels, and then whatever the current Y position is plus an offset of 3, just so we get it so it's not clashing with the border, it's not clashing with 1 pixel below the border, it's going to be the 3rd pixel down. And then we will then just say what the width and the height of this bar is going to be, which is just 2 and 4, and then 1 is just, is this black or is this white? So we want this to be, we're on a black screen, we want this to be white, which is 1. So that's how we do the first level. The second one is basically just a different offset. Everything else is the same. The third level is a different offset. And then the last one is 4 and 5 are also just different offsets. Right, so let's actually display this. We then have OLED.show, which basically just writes the frame buffer that we've just created to the display. We've then got a property and a setter, so a getter and a setter. So property, this little at and property word here, this is called a decorator, and you can put these on top of Python functions, and it basically does some extra stuff for you. So what this is doing is creating two extra functions, because if you notice, def level and def level have the same name, but behind the scenes they're getters and setters. So this one will get the current value of a level, and it will return it. So internally we're storing it as underscore level, so self._level. Again, that's the level of the battery between 0 and 5. And if we want to set the value, we can actually put some logic in there. And this is why we don't just have like the variable raw for people to change. By having a little function to check that they're passing in a valid value, we can get rid of loads of errors just by having this setter. So if we, for example, try to set the value of the level to be 6, which isn't possible, this will capture it. It'll say, if the value is greater than 5, then set it to 5, otherwise set it to 0, otherwise set it the current level to be whatever we pass in there. And then we've got another function. So this double underscore string double underscore means if you type print and the name of the class, it will run this function. So if you do like, if we create a variable called battery of type class battery level, I think this is called battery at level, and then we just print that out. So we just put it in some print statements. It'll run this. So it just returns battery level is, and then self.level. And the other thing I've done in this library is I've actually included a demo program. So this demo program is going to create a battery object using the battery level. It's going to put it at position 10, 10, so 10 X and Y, and then so it's going to be roughly in the middle of the screen-ish, and then 5 is the current level that we're going to set this to. We then set up the SDA and clock pins, the data from the clock pins at the ID is 0. We initialize our I2C variable object, and then we create an OLED display, and then we pass in that I2C. We just set the width and the height. The battery level becomes equal to 0, so that's using that setter function. And then we then say, while true, if the battery level is greater than 5, set it to 0. So it's going to count down, it's going to count up, sorry. So otherwise battery level is battery level plus 1. So it's going to increment those little bars. It's going to draw it on the screen on the OLED display that we've just created as an object, and then we're going to print out what the battery level is, and then we're going to sleep for 1 second. We can then say the battery level is now. This is just like me checking that things are working the way we expect. And then OLED.fill 0 basically just wipes the display. It's like a clear screen. And if the name equals name, if the name equals main, then it will run the demo. And that means if we run this this library, which is the battery level, it will actually run that demo program, whereas if we import it, it won't run that code. So it's only if we try to run this library. So it's a way of me creating this program without having to keep uploading it to the Pico and then running my demo program. So let's just run this one and see what happens. So on the screen there we've got a little battery, and you can just see there it looks like it's charging or something because the battery level's going up. That's quite neat. And it's very small, so that means we can put it on the top of the screen wherever we like. So we now go to demo number 2. We're going to import that battery level library that we just created. I'm just going to make sure I've got the latest version of that by uploading that to the Pico. So yes, I want to overwrite that. And then what we will do, so we're importing that. We're creating a little variable that's called bat for battery. We're going to put it as 106, so that's like 106 pixels to the right of the screen. 0 means it's on the very top row, the Y position, and the level will be 5, so the battery will be full. We're going to do the usual thing of creating our data, clock, and ID, creating a I2C object, passing that I2C object to our OLED display, which is using that driver there. And then we're going to do the same kind of thing, but this time I'm going to count down. So if battery level is 0, set it to 5, otherwise minus equals 1, so make it decrement by 1. And then fill the screen with 0, and I think because we're drawing it at the top there, well, that's interesting that we've got that after the sleep function, it will clear the screen, I see. Right, so let's run this one and see what happens. So you can see now it's at the top right of the screen, And I did experiment with the exact position of this. If it's a pixel further, you start to see it clipping off the edge there. So what I mean by that is if we go to here, so instead of it being 106, if we make that 107 pixels to the right, and we run this, you see there the battery, you can't see the very end line of that. So if we put that back to 6, we can just see there the edge of the battery. So that makes drawing this on screen nice and simple. There's no errors as well. It basically just throws that data away if you try and display something that's outside of the bounds of the screen. I've also got a couple of other things on this breadboard that I'll be starting to use. I've got a little buzzer there, and I've also got like a clicky on off switch and an LED as well. So I might be using those in the toothbrush as well. So they're the two demo programs that I wanted to show you there. I have uploaded this code online. I think it's called Pico SSD 1306 on GitHub. So you can follow along with this. I'll put a link in the description to the code just so you can grab this. Particularly if you want to grab that SSD 1306.py driver for displaying stuff yourself. Cool. So that is the demo I wanted to show you today. Let me see if there's anything else I wanted to cover off on the overhead there. So let me just zoom out. So yes, that display is basically going to sit on top of these components here, and there'll be a case that goes over the top so you can see that there, and there'll also be an on-off button as well as a sort of selector button, so you'll be able to select different menu items from that screen there. I did do a show a while back where I showed you how to create things like rotary display menus, but this one's simply just going to be a push button. There is on the LiPo, I'll just grab this one here for example, which is the same thing. This is one of these Amigo Pros. You can see there we've got a couple of different header things. We have a SW, which is the software switch, so we can basically toggle on or off the I'll just grab this and shove this in for example. Let's see if I can make this work. Of course that header pin's too big. Yeah, essentially you can short those two pins together there and it'll turn the I'm going to show you that and talk at the same time. Of course now it doesn't want to focus. So yes, if you short those two SW pins together, it essentially presses the power button on or turns the power button off. So that's a very simple way of making the thing come to life. And we can also run an LED as well, just to indicate that it's on, have another LED to indicate that it's charging as well. And of course we can take a reading from the VBAT. Again, if I'll just show you on there, the VBAT, there's a VDEV and VBAT. VDEV is the power that's coming out of the charger, I think, like the USB-C, and VBAT is the level that's coming out of the battery. So we can check that by just basically taking VBAT and a 200k resistors and making voltage divider. Cool. Okay, let's get back to our notes. So, one of the things I've been sent recently by Pimroni, and I've been waiting for this for so long. Chris has been working on this for almost like a year now, I think, which is the Yukon. This is an amazing board. So I've got this Yukon here. Don't think they're released just yet. It's going to be sometime in the next couple of weeks. And you can see there that this is a Raspberry Pi RP2040 powered board. You can see right in the middle there we have the RP2040. There's a great big capacitor on there to make our voltages nice and smooth, and we've got these removable modules. So we can actually remove these modules, and there's 6 removable slots there. So you can just see now we have slot number 3 exposed, and there's the little header connectors just there. And there's a whole bunch of these different modules that you can actually get. So this one is a speaker module for a mono with a mono amplifier built in, and we simply just connect this just by pushing it into the header. And there is a whole bunch of screws that come with this really nice brass screws to sort of screw them into place. We can build almost anything with this, so this is really modular, really clever. It reminds me of Thunderbird 2 with all the different modules that you can have on there. I don't know if they've channeled that with the the sort of hazard things that are on there, but yeah, you can just simply just pull these off. Look, 2, and then we've got space number 1 there. So there's 6 modular slots in the board, and there's a couple of boards that I think are going to be launched with the initial kit. So there's things like a dual motor bipolar stepper motor connector with got the nice terminals there. There's a quad servo direct. Now I just rotate this round, we can also see there is a quad servo regulated. There's an LED strip, and there's a big motor plus encoder. So you can see there's headers for the encoders, and there is two motors. A single motor can be connected to that. And I've actually got a bunch of other modules as well. So let me just get this the right way around. So you can see there we've got the three top ones are kind of, prototype boards you can build yourself. We've got the dual switched power output, the bench power step down DAC, and we have a serial bus servo as well. So there's a whole series of these. You can connect these together and make your own kind of robot device or whatever. You can make a bench power supply, LED strip controller, whatever. But look, it's got that great big connector on there. Was it an XT? I can't remember which type of connector this one is. I think I've got some XT30 connector on there, so you can get serious amounts of voltage into this, and it can handle it no problem. We've also got at the bottom there a couple of buttons. So there's a user buttons A and B. We have some breakouts there for breakout garden, so we can connect in anything with a breakout garden. There's two Quest connectors, them Stemma QT connectors. There's a power button, and there's a user boot button as well. So everything we would need, as well as a USB-C for connecting and programming this as well. So I can't wait to use this on something. And I was thinking about what can I actually use this on, and I've ordered through eBay a broken Omnibot. So I was thinking maybe I could get this Yukon working with the Omnibot, so I can do some kind of cool project bringing that to life. So the Omnibot was from Tomy. This is 1984 they released this. I always wanted one of these, but they're like super expensive. And they're actually still really expensive to buy these like working ones on eBay, like over £200, something like that. I got this one for about £30. I think it's broken. I've actually not powered it up yet to see. It doesn't have a remote, and I think the arm mechanism has like a broken piece to it. But I have got together our 3D print replacements. But yeah, we can do all kinds of stuff with this Omnibot, I think. And unusually it works by cassette tape. So I need to do a bit of research on this one. But those eyes, we definitely have to get those lit up. We definitely have to get this thing moving around, moving its arms, bringing me a nice Pepsi or something like that. But I think we can probably control all those motors by using the Yukon, because it's perfect for this kind of customization, this kind of project work. So yeah, you can see a couple of notes I've got there from Wikipedia about Omnibots. So yeah, that's definitely a project I'll be working on very soon. So if you want to learn some robotics yourself, I put loads of different courses available online completely for free with no sign up or anything. Just go to kevsrobots.com/learn/ and you can get learning today. There's ones on Python, MicroPython, robotics, databases, 3D printing, 3D design. There's all kinds of learning courses on there, all for free, and you basically just get learning today. We also have merch, so we have these amazing hats, Robot Maker hats, perfect for a gift for Christmas for someone who likes building robots. Particularly kids like these kinds of things if they're making some kind of kit. So you can get those from kevsrobots.com/merch, and there's quite a few other things on there as well, like the mugs and the t-shirts. And if you've not joined our Discord group, we have a growing community. It's got hundreds of people on there now who can help you if you have any issues with your code or anything that you've tried building from this channel. You can get some extra help on there, completely free. Just go over to kevsrobots.com/Discord to get a sign-up link, and you'll be joining and talking to everybody online. And you can follow me on social media as well by going to any one of the social media sites. So I'm on Threads. I think that's one of the growing platforms that I'm currently on. It's got a nice mix between what used to be Twitter and Instagram. It's got kind of a nice vibe to it there. I'm also on TikTok, Kevin McAleer6. I'm on Instagram at Kevin McAleer. I'm still on X at the moment at KevsMac. I'm on Mastodon at kevsmac at mastodon.social, and I'm also on Blue Sky at kevsmac.bsky.social as well. So if you follow me on those platforms, I'll say hi if you give me a follow on there. I also post all kinds of behind the scenes stuff there too. And if you want to support the channel, and we've had quite a few people support the channel quite recently, so I'm really pleased about that. If you want to get your name in the end credits, which I'll show in a minute, then you can go to kesrobots.com/coffee to buy me a coffee. I'm a big coffee drinker, so I really appreciate people do that. You can also do a super thanks. Let me just make sure we've got those notifications enabled on the channel right now. So yes, we have. So yes, if you do a super thanks, basically that's a way of buying a coffee through the YouTube platform. You can do a super chat, which is by a way of doing it sort of live now and popping up on stream, or you can join the YouTube membership program by clicking that little join button just underneath once you've subscribed. And to subscribe is free. So that's how you can support the show, and we have some supporters I would like to give a bit of a shout out to. So here we go. Yes, it's working. So we have, is it Kira Robotics bought me a number of coffees, so really thank you so much for that. We have a couple of members on the Buy Me a Coffee side. We've got Maria Louise Mayer, we've got Jeff Johnson, we've got Dean Corty, Marlene Brent, Tom Shemi and Steve Phillips as well. And then on the YouTube membership side, we've got Alistair Ware, who joined, was it last week? We've got John Paul Jolly, we've got Chris, Cassie, we've got Dale from Hybrid Robotics, Tinkering Rocks, JDM, Johnny Bates, Bill Hoy, Oxrad39, Hans from Cheerlights, Michael, and of course we have Tom as well, our longest subscriber. Thank you, Tom. Okay, so I think that is everything for the main part of the show. Yes, it is. So this is the point in the video. If you're watching this on replay, I'll say thank you so much for watching, and I shall see you next time.